So here we have our absolute value equations. We're going to solve by graphing. We're going to solve algebraically. Shouldn't be too bad of a lesson if you know how to graph. That is the big iffy. Alright, so the context here when we're dealing with solving by graphing is that we treat the right and left hand side as their own equations. So the right hand side is 2 absolute values of x minus 1 plus 2, and then we're going to treat that as its own equation. And then I said right hand side, the left hand side, and the right hand side is y equals 4x minus 3. So this guy is in the form of a times x minus h plus a k, and this guy is in the form y equals mx plus b. So you should know how to do this. You should. Anyways, on to graphing. Our vertex is going to be at positive 1, positive 2, about right there, and our initial slope is 2. Rise 2, run 1 both ways. Since we're solving by graphing, I've always found it's nice to put lots of dots. And I completely borked that thing, didn't I? It was right 1, up 2, put that in the right spot. So there's my v. 4x minus 3 is going to cross the y-axis at negative 3. It's going to rise 4 and run 1. And here's the issue with solving by graphing. Is where is it intersecting? You kind of have to guesstimate. It almost looks like it intersects at 1, 2. I don't think it will, but it kind of looks like it intersects, at least close, to x equals 1. Again, I just made something up. I had no idea I was going to intersect. So that's the weakness of graphing. Graphing is not a very good way to solve, at least when you're graphing by hand. But the graph is telling you that there is an intersection, that there is one solution. Algebraically, is by far superior, although it is more time consuming. So what we have to do is we have to first isolate absolute value. That's your first step. First, isolate ABS. So we're going to subtract the 2, because that's an easy move. 4x minus 5 equals 2 absolute values of x minus 1. Now, I could divide this 2 out, but then I would have a funny looking fraction on the right. So instead I'm going to distribute this 2 in. I have the absolute value of 2x minus 2 equals 4x minus 5. Now that I've isolated absolute value, I'm going to write 2 equations. Okay? The first one will be as is without the bars. So 2x minus 2 equals 4x minus 5. And this is a hard skill for kids to know that they're supposed to write 2 equations. On the second one, I negate the sign of the stuff inside. So what's negative becomes positive, what's positive becomes negative. You leave the right-hand side alone. It's just the stuff that's inside the bars that you change. And then we just do some algebra, man. So I'm going to shift the 2x over here. 4x, take away 2x is 2x. I'm going to shift the 5 over here. And negative 2 plus 5 is 3. And I get that x is 3 halves. So it was close to 1. It was 1.5. And that's the problem with freehand graphing. I guess my guy should have been over here more. Alright, this one, what's it going to end up looking like? So we're going to add 2x to 4x, and we're going to have 6x, and we're going to add 5 to 2, and we're going to get 7. And this is the answer that I actually saw. Because if I take 7 divided by 6, I get 7, 6, which is really close. Now what's interesting is my graph only suggests 1 solution, but algebraically is suggesting 2 solutions. Interesting. Well, it only has 1 solution. I ain't going to cross that thing twice. So this is something for a later day. That must be something we call extraneous. I'm a little confused as to why that showed up, but it did. I didn't make a mistake, did I? 2x minus 2. Took away 2, added 5. I don't see anything. Anyways, it's 7, 6. It's the right answer. All right, what's the next interesting one? Probably number 3. Yeah, we'll do number 3. So before we do anything on number 3, you're going to have to do a little factoring on this guy right here to graph it. Both 4x and negative 8 are divisible by 4, so we can factor that as 4 absolute values of x minus 2 and then plus 1. And it equals a negative 3. So again, we're going to treat one equation as the left-hand side. It's going to be 4 absolute values of x minus 2 plus 1. Then we have another equation that says y equals negative 3. And that's the gist of it. So let's focus our attention on this guy right here. We have a vertex at 2, 1. And we have a slope of 4, rise 4, run 1. There's my v. And then we have y equals negative 3, which is down here. And you can quickly see that we have no solutions. So there's something the graph gives you. The graph is telling you there's no solutions. Algebraically, let's see what happens, okay? Because it is possible for you to come up with solutions algebraically. So the first thing we would do is we would isolate absolute value. And most kids wouldn't realize this, but you are already done. Because this says distance is negative. That is what it is claiming. But you're already done. But now here's what most kids do. Most kids go ahead and they write the equations. And this is wrong. But they'll say 4x minus 8 is negative 4, or negative 4x plus 8 is negative 4. Of course, we add our 8, we get 4x is 4, and x is 1. Or we subtract our 8, negative 4x is negative 12, we divide by negative 4, or x is 3. It's hard for kids to realize that there's a stopping point. The stopping point was actually right there. You can't have negative distance. It doesn't exist. All right, some solve algebraicallys. And as you do these, again, pay attention to the idea of negative distance. I don't want to do too many of them. I think I'll do 6 and maybe 7. So first step on 6 is perform your isolation move. If we add 2 to negative 1, we get 1. And that's what it looks like. You have a choice here. You can either distribute the 2 or divide out the 2. I'm going to divide out the 2 because we want to isolate the absolute value bars. Now I can write my two equations. X minus 5 equals 1/2, or negative x plus 5 equals 1/2. If we add 5 to both sides, that'd be 5.5, or it would be something like 11/2. If I subtract 5, I would have a negative 9/2. If I divide out the negativity, I get positive 9/2. And those are most likely valid answers. They really are most likely valid answers. This one's bothering me. Did I misdraw it or something? I don't know. I'm surprised that I got a second answer there. It's interesting. See, that's the thing about graphs too. Graphs tell you truths. They do. One of those answers didn't make sense on the first one, but we're not ready yet for the discussion of extraneous. And let's see here. Let's do 7. Now on 7, you need to isolate an absolute value sign. And this one's already isolated, okay? So that's the one I'm going to work with. It's already alone. We're just going to write two equations based off of it. 2x minus 3 is equal to 1 plus 3x minus 4. Or negative 2x plus 3 is equal to 1 plus 3x minus 4. You only have to change the signs on one of the absolute values, and everything else should work its way out. You don't have to write 4 equations, 2 will do it. Anywho, let's shift my x's left and all my numbers right. So 3x minus 2x is simply an x. Negative 3 minus 1 is negative 4. Add 4, we get 0. So x is 0. Moving on to the second one, we'll add 2x to 3x. That'll give me 5x. And if we subtract 1 from 3, we have a 2. If we add 4, we have 6. Divide out the 5, and there's my 6/5. So 2 answers there, 0 and 6/5. Should probably be checked against the graph, but whatevs. All right, using the zero product property, hopefully by Friday, more of you have the zero product property down better. Zero product property says if, let's change colors here so you can actually read that. If A times B is equal to 0, then A is equal to 0, or B is equal to 0. One or both of them are. So I say these things are the zero product property. This is A, and this is B. Now this one down here is an extension of the zero product property. You have an A, a B, and a C, and they're all going to be equal to 0. But I'm going to look at number 9. A is equal to 0, or B is equal to 0. So if I'm doing number 9, 2x minus 7 is equal to 0. Or the other factor, x plus 3 is equal to 0. They're both easy to solve. 9's a two-stepper. Add 7 to both sides, divide by 2, 7/2, call it a day. This other factor, x plus 3, that's a one-stepper. Subtract 3 from both sides and be done with it. Move on with your life. Do something else. Don't waste your life doing your math homework. Then we have factoring practice. I don't want to do all of these, but let's look at 9. So whenever you start off with your double set of parentheses, the thing that goes first is going to create 9x squared. And my gut says 3x and 3x. And I've told you this, pick the factors that are closest to each other. Now to make a 16, you're probably going to be using a 4 and a 4, because 4 times 4 is 16. Kids really struggle at factoring because they're pretty bad at basic math. They didn't memorize their multiplication tables. That's where kids usually factor. Now think about when you do the double distributive property, how you link terms, okay? These guys get linked together. That's a 12x and that's a 12x. But you'll notice that this thing has no x's in the middle. So I need these guys to cancel each other out. So one of them's positive and one of them's negative. And there you go. 3x plus 4 times 3x minus 4. It's actually what we call a difference of two squares pattern. Another one I'll do is 13. The only way to make a 3x squared is to use a 3x and an x. 7's pretty easy numbers to work with. It's going to be 7 and 1. And let's think about what was made here. 3 times 7 is 21x. 1 times x is x. I want a positive 20, so I need the 21 to be positive and the x to be negative, because 21x minus x is 20x. So positive, negative. And there you go, boys and girls. That's exactly half your homework. The other half is for you. I do more, but my voice is about shot.